Hey friends, I'm Scott Hanselman, and it's another episode of Hansel Minutes. Today I have the distinct pleasure of chatting with Maynard Holliday. I could spend the next 30 minutes talking about Maynard Holliday and all the things that he's done. He performed the duties of Assistant Secretary of Defense for Critical Technologies in the Office of the Undersecretary of Defense for Research and Engineering, and he has been a roboticist probably since he could walk. His resume is long and storied, and we are very fortunate to have him on the show today. How are you, sir?
All right, good to be with you, Scott.
So we have to point out for folks that are listening and not seeing this, some folks will see it on YouTube, some folks will be listening in their car, but behind you is a wonderful series of Marvel characters. I see Captain America there in the form of Falcon. I see Storm. I see Black Panther. Are you a comic nerd from way back?
I am. Original Marvel true believer from the Stan Lee, Jack Kirby years, and some of my earliest motivations come from the comic realm.
How important
Iron
was
Man,
that, though?
yeah,
Iron Man?
Very important.
Yeah.
Tony Stark has no superpower but his mind, and so that made an impression on me, as a young boy, and then to see reflections in comics of people of African descent in positions of power, authority, and knowledge. And Black Panther, T'Challa in the comics is the chief scientist of Wakanda, not Shuri as depicted in the current MCU. And so T'Challa, in his instantiation in the comics was an early role model for me as well.
And also, people can see you've got the, looks like NCC 1701, the original Enterprise in the back there, which I would assume then means that you're a Trekker or a Trekkie,
Absolutely.
depending on who you ask.
Yep.
And it's worth noting, of course, that, Richard Daystrom was in the original series,
right?
One of the chief geniuses that was compared to Einstein. He's compared to, he basically created like all the computers in the 23rd century, and he did it when he was in his mid-20s.
Right.
Was it so important to see that when you were growing up and just
absolutely.
say, yep, I can do that too?
Absolutely. It was pivotal in my, early development to see that strong, African, well, not American, he was from some other planet, by the 23rd century, but to see him represented, and as you said, Scott, he architected, the compute for Starfleet.
Right. Basically the cloud, Starfleet's cloud.
Right. And so that was a powerful, inspiration for me, as a young boy who was, looking to, kind of define what I wanted to do with my life. And both Tony Stark, T'Challa, Richard Daystrom, early inspirations for the career that I eventually embarked upon.
And you went to Carnegie Mellon for your
Right.
undergrad, and then you finished up with a master's from Stanford.
Right. Yeah. So Carnegie Mellon, where I majored in mechanical engineering and got the robotics bug there, was in school when 3 Mile Island happened.
Oh, wow.
And Carnegie Mellon, one of the now emeriti professors, Red Whitaker, the father of field robotics, which is the practice of robotics, in the environment, not in, factories or very, controlled environments, was contacted by Westinghouse, the owner of 3 Mile Island, to develop robotics to help characterize what was going on, at 3 Mile Island, to make sure, there were no radioactive leaks and to help remediate it. And so that was an early inspiration for the robotics that I did later in my career.
Yeah, because for context, for folks that may not remember, 3 Mile Island, 1979, was a partial meltdown, had minimal radiation release, but it changed how people felt and thought about nuclear And then Chernobyl happens just 7 years later, except Chernobyl was not a partial meltdown. It was catastrophic. And it wasn't a pressurized water reactor. It was an RBMK, graphic moderated reactor.
Right.
At this point now, you're out of school?
Yeah, I'm out of Carnegie Mellon. I had already gotten a scholarship and had finished Stanford in '88 with a master's of science in mechanical engineering, where I concentrated in robotics and arms control because I was at the Lawrence Livermore National Lab.
Mm-hmm.
And so, as you mentioned, Chernobyl happens, but fast forward to, as they like to say, when peace breaks out
Mm-hmm.
in the early 90s and the Soviet Union disintegrates, we as a government decide, and rightfully so, to spend a few $1 billion more to help stabilize these newly independent states.
Mm-hmm.
And we wanted to engage the Ukrainians, who, in exchange for Western aid, sent all their nuclear weapons back to Russia and became, for a brief period of time, the number 3 recipient of U.S. foreign aid behind Israel and Egypt. And I was part of that foreign aid in the mid 90s, where I went to Ukraine to work with an institute that did the guidance and control for the Soviet ballistic missile force,
Mm-hmm.
so that they wouldn't migrate to rogue states back then, Iran, Iraq, North Korea.
Mm-hmm.
So we wanted to gainfully employ them on things of mutual interest. And when we got there, they said, "Hey, we need help at Chernobyl." And so that's how I began working with the engineering team at Chernobyl on, how to stabilize and characterize the sarcophagus that was hastily built right after the accident.
Mm-hmm. And the sarcophagus is this thing that goes around it. It's a containment zone.
Right, exactly. So it was hastily built right after the accident, and it was crumbling, and they feared a secondary release of radioactive material. So they needed a robot to be able to go into the basement, specifically room 305, where what was called the elephant's foot, which was a amalgam of graphite, as you pointed out, the fuel plus, the radioactive or a radiological absorbing material that the helicopters drop to help mitigate, the reaction, of the explosion that happened. And so there's this amalgam of material that had solidified, and, they needed to characterize, what the radiological, footprint, both virtually and figuratively, was. And so the robot to get into this room. So we helped, design that, with help from Professor Whitaker and his spin-off company called Red Zone that did the robots for 3 Mile Island.
Right. So Red Zone comes up with an agreement between Lawrence Livermore National Laboratory and NASA and the DOE and Chernobyl. This is all these groups working together back when everyone could work together.
Right.
And said, this is a problem. We got to do this. But you can't get anywhere near it as a human. What does radiation do as a robot? To a robot? Is it a processor issue? Is it cameras? Is it wiring?
Yeah, so kind of all of the above. It embrittles, elastomers, and also has an effect on electronics. And so one of the unique things, that we did for the robot was make it modular, in the sense that components could be unplugged and then decontaminated. But the key, design feature was that we made it tethered, so that most of the electronics were off board, and the robot just got signals. And so there was a control panel, and so we, this is well before, more robust kind of wireless technologies, and so the robot was tethered. The tether was structural, meaning it, if the robot failed, it had enough strength that you could, pull the tether and then pull the robot out. And another key design feature was we polished lead to optical quality so that the CCD cameras would not have to look directly into the solid angle of, radiation and then cause the CCD pixels to ionize. And
Wow.
so this, the CCDs were off axis, looking at, reflection where,
Right.
lead would shield, so to only get the optical
So you
wavelengths.
bounced it off of a lead mirror.
Exactly.
Wow, that's like pinhole cameras, or how,
Mm-hmm.
interesting. Would you consider Pioneer, this robot, a robot or a remotely operated machine? Is it
Teleoperated. Yeah.
teleoperated? Okay.
Yeah. So that's how I'd characterize it.
Yeah.
The only thing that was automated was the vision system that
Mhm.
NASA developed to map the room. And so you didn't have to manually actuate the vision head.
Mhm.
It could automatically survey the room and create a 3D map.
Mhm. There's a bunch of funny people online that are looking at like the moon footage and now the Mars footage, and they make the comment that we have these better cameras on our iPhones now than we ever had when we were off in space. And they've also noted that the Loch Ness monster and Bigfoot and all of these things that we want to see have never shown up since everybody got a 4K camera in their hands. Tell me about the camera technology. What are we looking at here? Is it analog? Is it low resolution? Are you able
Yeah.
to see what's going on?
Yeah. So it was low resolution, so think about it. This is, 19, early 90s technology.
Hmm.
And yeah, nowhere near, 4K resolution. And the other thing that happened was once we delivered the robot, the Ukrainian government said, all the data at Chernobyl is classified by the state.
Oh
and
no.
and so that's one of the disappointments, that the data was never shared with NASA, because one of the attractants for NASA to even join the project was they wanted an analog for an interplanetary environment, because they go to Mars, and this is, still to this date, the world's worst nuclear accident. So this was an analog for an interplanetary environment, and they wanted the data, which unfortunately they never got.
Hmm. Yeah. The so even now, is that you can't get them on the corn and get that data back?
So let's fast forward to the outbreak of the Ukraine Russia conflict.
Mhm.
I'm sitting in the Pentagon, in my position, as assistant secretary for critical technology, and I get a message on my LinkedIn profile,
Oh wow.
because that's the only social media I'm on, from the people who I used to work with at Chernobyl. And they were like, help, the Russians have come and have damaged our equipment. We need help. And so what I was able to do was put them in touch with a Department of Energy nuclear safety working group, because the Russians had taken over Zaporizhzhia, if people remember,
Mhm.
which is Europe's, biggest nuclear power plant. They
Mhm.
had taken it over and were lobbing shells at the Ukrainians, because they knew the Ukrainians couldn't retaliate because it was a nuclear site. And so, anyway, the Russians are at Chernobyl, busting, I won't swear, busting
Mhm.
stuff up. And so what I did is I put them in touch with this nuclear safety group, who was able to get them computers and other things to help them monitor the condition of the new sarcophagus, which I think was completed, probably less than a decade ago now, by
Hmm.
the European Bank for Reconstruction. So they put a, large, like, hangar type structure over Chernobyl Unit 4. But then the Russians attacked it and flew a drone into it and caused it, put a hole in it.
Oh no.
So yeah, so before this conflict broke out, they had contacted me because they wanted help designing robots that would be gantry like to disassemble the original sarcophagus and uh, size reduce the nuclear fuel.
Wow. Wow. In your role now, like, are you connected to these things? Is it one of those things where, with all due respect, there's like aging people in this area that know stuff, and
Mm,
when I'm gone, when you're gone, who's going to know these things?
yeah, yeah. So great question. I have my own little LLC that
Hmm.
I strategically advise companies that have technologies that were germane to my old portfolio.
Hmm.
Um, and I just from afar keep tabs on what's going on in the Russia Ukraine conflict. So
Hmm.
I haven't closed the loop with any of the people back at Chernobyl.
Hmm.
The Russians eventually kind of left because they were getting irradiated.
Yeah, I mean, nobody wants to be near there right now.
Right. And so they left. So I think that the situation there has stabilized, and I think they patched the hole in the roof,
Hmm.
and so that's as good as
Yeah.
we can expect right now.
Pivoting a little bit, you helped establish the original Defense Innovation Unit experimental, which was intended
Right.
to connect the Pentagon with commercial technology companies. And
Yes.
as a civilian myself, who is often talking to startups, I feel sometimes like founders and startup people, they get stars in their eyes and they go, "Oh, our product works. We should get the Pentagon to buy it." I'm curious what founders misunderstand when they have
Yeah,
that level of
yeah,
ignorance.
sure. So back in 2015, then Secretary Ash Carter gave a speech at Stanford called "Rewiring the Pentagon,"
Hmm.
and in that speech, he rightly uh, pointed out that the global market, the addressable market, is driving innovation, and the Defense Department, who used to be a big customer, was now a niche customer and needed to first and fast follow industry.
Hmm.
And so he wanted to create this Defense Innovation Unit to do just that. So I spent the summer of 2015 talking to my former colleagues out here in Silicon Valley about what would bring them in to work with the government. And to your earlier point, Scott, about what founders sometimes miss is what is the military problem that you're solving. And so one of the things that we learned in doing a survey of other similar institutions, InQtel has been in the Valley for, kind of decades before DIU, and their secret sauce was being able to write unclassified problem statements for classified intelligence community problems. And so this
Mm.
is one of the things that we adopted uh, on the DIU side is we took military, bespoke military problems and wrote what we call commercial solutions offerings. So we would put a problem statement, an unclassified problem statement, and this is still the case, with DIU now on the website and open it up to industry, to startups. And so rather than to your earlier point about a company saying, hey, the military should buy this, companies can now look at a problem statement and then develop technology or change, a given technology or system to solve that, very specific problem statement that the commercial solutions offering is stating. And so
Hmm.
so DIU has or had, liaison officers from all the services who knew, from their, you know, from big Army or big Navy or big Air Force, what problems they would like industry to solve. and so they would then be able to put these commercial solutions offerings out, and then, like Shark Tank, get pitches from these companies, and then shortlist them and then get them under contract. And that was one of the things that my former Silicon Valley colleagues told me was, hey, we need to get these people under contract, not on a year time scale, but within weeks, 2 months at the most, because you got to move at the speed of Silicon Valley business.
Right. Now, you've described that products go through kind of three processes, and there's three potential, what you call valleys of death, places where things stop. Going from the lab to a prototype, that's a moment where you can screw it up and it's over. From prototype to product, and then from product to scaled production to actually happening. And then your advisory work is focused on, crossing that gap. Right. How often do companies just fall directly into that valley of death? And it's like, hey, it worked in the lab, but it's not not going to be production.
Right. So very often, and the Defense Department, has recognized this. And when I was in office, we stood up the Office of Strategic Capital, which is the only group in the Defense Department that is doing loans. And so they loan companies that have capital intensive projects, funds to help them bridge, those valleys of death that you describe, from lab to prototype, or from prototype to product, and then product to scale. So so there's a whole suite of government programs, the Small Business Innovation Research Grants, also known as SBIR, and they're phased, from 1 through 3, and the dollars amount go from 6 figures to 7 figures. And there's DIU, is a funding source. They're all the software labs, AFWorks and SoftWorks. So there's a myriad of funding mechanisms to help companies bridge those various valleys of death.
And now we're in a moment where we've got cheap drones, arguably cheap and on the edge AI, theoretically small and medium-sized language models that could even run on a drone. You worked on a tethered teleoperated robot. Now one, if one wanted to, has the Lego pieces available to make a drone. I could do it myself in a weekend. I could make a drone that could do something bad and make it autonomous and send it over anywhere. You've called these high stakes AI, and you've got some strong opinions about what we should do about these things. We need receipts.
Right. So these drones, have changed, warfare. And, when I was in office, and getting, my regular intelligence briefs, we would see, these one-way attack drones, essentially, almost single-handedly obsoleting armor as a vehicle of a maneuver. And so unless, you had, some very robust, cages and even the explosive armor that protects you from side projectiles, our Javelin system that, has a ballistic trajectory and goes straight down on the turret, made that kind of protection obsolete. But, drones and the fact, and one of the things in military jargon, quantity has a quality all of its own, right? And so if you're able to saturate, an enemy's air defenses, have too many targets for an air defense radar to track, and this is what you're seeing on both sides now, and it's escalating, and the counter systems, that are using, electronic jamming. And so you're seeing a lot of tethered drones now
Hmm.
that are immune to that jamming because the signal is going through the tether, and is not going through the electromagnetic spectrum where
Hmm.
it could be jammed. And so, like I said, it's evolving, and the U.S. has recognized we're behind, but need to catch up in these attritable assets.
Yeah. But commercial companies, and certainly in the world of in the world of AI, the time of AI, are moving extremely quickly, and it's very much a move fast and break things situation. Certainly, offense gets to move fast and break things, but is it fair to say that defense systems demand assurance, and there's a certain amount of caution that needs to be put together before something is deployed? How do we balance that? Like, things are moving so fast, but we really need them to not move fast.
Well, we have to be comfortable with iterating. And so, in Silicon Valley, they iterate, on the software side. And what, SpaceX has been able to pioneer is, that fail fast and then iterate. And, you can look at the timeline of, the evolution, of their engines, for the Falcon 9,
Mm-hmm.
from a part count to, where they started and to, where they are now. And, it's remarkable. And so we have to be comfortable with iterating, at speed and not having, waiting for the 100% solution, but being satisfied with the 80% solution.
Yeah. But then, of course, you get back into the valley of death in the sense of the 80% solution may be very inappropriate 20% of the time.
Right. Right.
Yeah. So I'm curious. I'm 53, and I am overwhelmed with existing this long and looking back at when I started on a Commodore 64 in 1984. And now we have pocket supercomputers that talk to the world AI. And, I'm curious, with even more historical context that you have, how often on a random Tuesday afternoon do you just kind of go, holy crap, I'm living in the future?
Yeah, I have to pinch myself sometimes to say, you and I talked about this earlier. The Star Trek technology that was supposed to be 23rd century. We have realized now. The communicator is the cell phone, right?
Mm-hmm.
Being able to talk to your computer, like Spock and Scotty, did
I,
in the series.
I always use that Star Trek 4 when they're going to save the whales, and he
Yeah,
sits down on the Macintosh and he's like, computer?
right.
Oh, just use the keyboard. Oh, how quaint.
Right. But now we can do that.
Yeah.
We can voice prompt, Claude and Chat GPT. And so, so I'm excited, that these technologies are, being realized,
Mm-hmm.
and, and then, science fiction serves to, kind of, be that engine of innovation. And I remember, this is and I don't remember what DARPA program. So for, the uninitiated, DARPA is the Defense Advanced Research Projects Agency, which gave us, the internet, which gave us, the GPS constellation that we depend on for navigation and other things, and the miniaturization of accelerometers that tell you which way the gravity vector is pointing. These small cameras. But I remember a DARPA program manager showing a clip from Minority Report. If you remember, when Tom Cruise is trying to hide from the pre-crime team, and they put the spiders
Yeah.
under the doors,
Yeah.
and a program manager said, I want that. And so, so you think about it, uh, these science fiction, kind of concepts, help motivate the imaginations of, engineers and scientists, and obviously of the military, to look for things that would help our war fighters. And
Yeah.
and so what DARPA does is buys down technical risk, and invests in things that are not yet commercially viable, but have a military utility.
From a less military utility perspective and a human perspective, I could say that I am thrilled with my robot vacuum.
Mm-hmm.
I'm curious if you have robots in your house, and
I
what
do.
robots do you want in your house that you don't have yet? I feel like the clothes folding robot that's the next one.
Yeah, but so I'm going to be a little contrarian here. There are other people who, in the robotics community, may disagree, and some may agree. But I think humanoids are the wrong form factor
Mm.
for home. So I would qualify that to say, the upper torso is, so a torso with, a 6 degree of freedom arm with, at least 3-finger end effector. But bipedal locomotion is really hard. And I would point back to the DARPA Grand Challenge, where it was used to replicate the actions needed to mitigate what happened at Fukushima. So the bipedal robot had to drive an ATV and get out, open a door, use a tool, open a valve, which was key in the Fukushima scenario, because they couldn't, get the cooling water, to, the reactor cores. And so they had the explosions. And so the robot that won it had was hybrid. It could walk, but it also had a wheeled base to allow it to go over, kind of an unstructured, uneven terrain. And so in people's homes, there are stairs and things like that. And, there was a robot that I worked with, again, in my Lawrence Livermore days, called the PackBot. And its architecture, the remit from DARPA was, hey, we want to replace the point person in a platoon, because, that person, draws the fire and is, the one that gets taken out at the base of a staircase. And so the robot had to be able to climb stairs. And so, the company that unfortunately, went bankrupt recently, iRobot, developed the PackBot that had these folding kind of treads that allowed the robot to climb stairs. And so I think, the form factor that will be successful in a home is going to be, a torso with, like I said, the same degrees of freedom as a human, or maybe even more. But the base is going to have to be some hybrid of tracks and wheels to get over uneven surfaces.
Yeah, I think you're right. I think roboticists and ones that are insistent on humanoid robots need to understand that humans are funny shaped things generated over billions of years of evolution, and we may not be the optimal shape.
Right.
Yeah.
Right.
Absolutely. Well, I could talk to you for hours. You are an absolute joy. I would encourage people to check out your website at maynardholliday.com. You're doing a lot of really great work in this space. You're a national recognized leader in security strategy, defense innovation, and you certainly help people bridge that space between commercial and defense. And we appreciate the work that you've done over the last several decades.
Yeah, it's honor and privilege, to have served in 2 presidential administrations. And, I want to make sure, we maintain our technological edge. So as my old boss used to say, to make sure our soldiers, sailors, airmen, and guardians are never in a fair fight.
And we appreciate their service. Thank you so much, Maynard Holliday, for chatting with me today.
Yeah, my pleasure.
This has been another episode of Hansel Minutes, and we'll see you again next week.